Hello everyone, this is Arpit from Algorency and welcome to the array lecture of the Algorency data structure video course. In the last video, we discussed the definition of data structures and what purpose they serve. If you haven't seen that video yet, I encourage you to go check it out. The link to the video is in the description box below. In today's video, we are going to learn about the most famous and most used data structure of all times, array. Let's read the definition and try to understand what it's trying to tell us. An array is a data structure that contains a group of elements. Typically, these elements are all of the same type, but not in languages like Python and JavaScript. We can have multiple values with all different data types in Python and JavaScript and others. By the way, if you don't understand what data types are, there's a link in the description for the data type video. Go check it out. So arrays are commonly used in computer programs to organize data so that a related set of values can be easily sorted or searched. Now I'll give you a moment to really soak in the definition, and if you need more time, just pause the video, read it and continue. Okay, we heard a few words there that we haven't heard before. First, a related set of values. Second, sorted. Third, search. I'll get back to them, but first, let's take an example. These are some values. They are all of the data type float. Suppose these are my semester's GPAs. Each entity here is a value and we have a bunch of them. So they would be called a set of values. So what relation do they all have? Well, they are all the GPAs of a person and they share this relation with each other. Let's arrange them side by side. So here we have the first thing down, a related set of values. Once we have the related set of values, we can do all kinds of stuff with it now. If we want them sorted, we can put them in an ascending order and the first element will be the smallest one of all and the last element will be the biggest. If we want to search for a particular GPA, we can do so in the array too. There are a lot of algorithms to search for an element in an array that go from linear time complexity all the way to big O of log n time complexity. The most famous one is binary search, which needs the array to be sorted beforehand, whereas linear search does not need the array to be sorted. Here you can see what an array is usually depicted as visually. Here each box in the row is an empty space to put the value in it and the entire row itself is the array. Each box has an index assigned to it, which actually works as its position in the array. The first box has the index of 0. And why 0? Why not 1? It is the first box. 1 makes more sense, right? Well, almost all languages and technologies around the world have agreed to put the first index of an array to be 0. Now the index of the second element would be 1. That's right, we start counting from 0 in programming and then head forward all the way. So the index of the third element would be 2, the next would be 3 and so on. Let's see how an array works like. Suppose I have just started my engineering and we have an array named marks of size 8. That means it has 8 empty spaces in it that needs to be filled. The first box would contain the first semester marks and the second box would contain the second semester marks and so on. So initially we have 0 in all of them, but as I pass each semester, we will update the marks one by one in each of the boxes in the array. And here is how. Suppose I got 7 GPA in my first semester and we want to put 7 in the first box. How do we do that? In most languages and pseudocode, it looks something like this. Marks at 0 is equal to 7. Now why 0? As I told you earlier, the counting in arrays start with a 0 instead of 1. So if we want to update the first box, we would have to give it an index of 0. Now suppose I got 6 GPA in semester second. I would similarly put it in the marks array. Marks at 1 is equal to 6. And we'll continue doing so. But in semester 5th, I failed an exam. And this semester, my GPA is low, like 5. And I have a back subject now. but still we will fill the box with 5. Now in the next semester I get 8 GPA and I also clear my back of the last semester, and the new GPA of the 5th semester is 6.5 now. I would fill the 8 GPA in the 6th semester box and also update the 5th semester GPA by writing this code. Marks at 5, which is the 6th semester, is equal to 8, and marks at 4 now is equal to 6.5, and then continue to fill up all the other semester marks. Now we know we can fill each box or empty space in an array and can also edit the values when required. Now that all the values are in place, suppose we forgot the values and wanted to know what was the GPA in the 3rd semester. We would simply print out the value in the 3rd box by our marks array. How? Well, we know that the 3rd box has the index 2 because of the zero based indexing we discussed earlier, which means we can simply say print the value of marks at 2, or we can write it in code as print marks at 2. As we have all the values in the array, we can even sort the array in ascending or descending order with the help of several sorting algorithms like merge sort, quick sort, etc. If we wanted to look for an element, we can use algorithms, linear or binary search based on the array's current state. Let's talk about array time complexities. Accessing a value at any position is known as getting the value, and it takes constant time, which can be denoted in the big O notation as big O of 1. Filling or updating the value is known as setting the value, and it also takes just constant time, that is big O of 1. Sorting the array takes variable time depending on the algorithm. Like merge sort and quick sort take big O of n log n time, and others like bubble sort and selection sort take big O of n squared time. Similarly, searching for an element can be at most linear time, big O of n by linear search, to big O of O log n time by binary search, if the array is sorted. Let's look at the array's code implementation. In Python, this is how we declare an array of some length. The array's name, then the equal to symbol and the square brackets, inside of which we put the desired initial value of each box and an asterisk followed by the length we want our array to be. For our example, it's 8. And this is how we set an element. This is how we get it. Arrays in Python are actually Python lists, so they are expandable even more than initial size, which is not the case in other languages. In other languages, you would have to declare a new array if you want a bigger array than what you initialized it with. Python also has an inbuilt function to sort the array. You can use it by writing the array's name dot sort parenthesis like this. Not a very complicated code implementation after all, right? That is all for arrays, guys. In the next video, we will study matrices or nested arrays or 2D arrays, whatever you want to call it. Like if you like the video, subscribe if you want more of such content, and for feedback and doubts, use the comment section. Thank you for watching, guys. I'll see you in the next video.